Hi, everyone, and welcome to Unit 8. So today we're starting a brand new unit. We moved on from Unit 7, which was all about circles, and obviously this is geometry, so we're going to continue talking about shapes. And during this unit, all of the parts, really what we're going to focus on is finding the perimeter and area of 2D shapes. Now, remember what 2D means? This is like flat shapes, right? Not 3D figures. And so, triangles, rectangles, squares, parallelograms, rhombuses, kites, trapezoids, those are the kind of shapes we're going to work with during this unit. And we're going to take them one at a time. So as you can see, today we're going to talk specifically about triangles and rectangles. Now, real quick before we get started, one thing I do want to mention specifically about this unit is it can be pretty challenging. And it's not that it's complicated to understand what to do, but the issue with this unit, and really it's the biggest challenge in geometry as a whole, is that as geometry builds on itself and builds on previous topics, um, it utilizes old skills for you to try to now understand and work with the new skills. And so what I mean by that is this. If you look down at problem 1, 2, 3 and stuff here, you'll see like degree measures in the angles, right? And then we can look at different sides, call them opposite. We can call them hypotenuse. We can call them adjacent, which means we're going to have to use sine, cosine, tangent. We're definitely going to have to use Pythagorean theorem here. We're going to have to remember things like vertical angles and linear pairs and just different things like that. And so even though that's not the basis of this unit, the basis of this unit, again, is finding perimeter and area, we have to remember those skills so that we can actually find perimeter and area. And so, again, that's going to be one of the most challenging components of this unit, but by no means should we back down. You guys can do this. You've been doing a great job. And so let's get to it and let's start to feel comfortable about finding areas of triangles and rectangles and perimeters, I should say. So we're going to start with perimeter. And what perimeter is just defined of as is the sum of all sides around a figure. And then just remember, the word sum means we're going to add, right? And so we're just going to add up all the sides of a figure. But in order to do that, we need to know all the sides of the figure. And so down in problem number 1 here, we don't know this side, it's labeled X, and we don't know that side, it's labeled Y. And so before we can find the perimeter, we have to figure out what X and Y are. And that's where the challenge of this unit lies. And so let's do that. And we're going to start with just a review of Unit 6. And Unit 6, the sine, cosine, tangent thing, it's going to be a huge, huge component of this Unit 8. And so let's feel good about this and we'll talk it through quite a bit here. All right. And so remember, if we're going to find X and Y based on an angle measure in a right triangle, we highlight the angle we want to use. And then we label the sides of our triangle as opposite, which is across from the angle that we're looking at. Remember, hypotenuse is always across from our 90, which then leaves where X is, the side attached to the 37. That's not the hypotenuse, the adjacent side. And so now the question is, we got to find X and Y. And so let's say we want to find X first. So obviously we have to use the X side, and then we're going to want to use the side that has the number as well. And so that means in order for us to find X, we want to work with the opposite side and the adjacent side. So let's remember our acronym that helps us, which is SOHCAHTOA. And so if we need to use opposite and adjacent, we need to work with TOA. Remember, O and A stands for opposite and adjacent, and so then the T in TOA stands for tangent. We want to use the tangent function. And so we're going to do the tangent of 37 equals, and then it's opposite on top of adjacent. So 18 divided by X. And then just a refresher of how we solve for the X in the bottom of this fraction. Remember, we always multiply both sides by what's in the bottom. So we're going to multiply both sides by X. And that's going to cancel our X's on the right. And it's just going to leave us with, come on. And it's just going to leave us with what was on the top over there. So 18 now on the right. And then we have that whole thing on the left, X times the tangent of 37. And remember, we want x by itself. And also remember, the tangent of 37 is just a number. And so we can simply just divide both sides by the tangent of 37. And when we do that, on the left side, the tangents of 37 cancel each other out, which leaves us just with x. And then 18 divided by the tangent of 37 is what we want to type into our calculator. And when we do that, we're going to get a decimal, and that's going to be the value of x. So let me help you with the calculator as well. I know that was a tricky part back in Unit 6, and so let's talk calculator real quick. So again, what we want to type into our calculator is 18 divided by the tangent of 37. Make sure you are in degree mode. So I'm going to check again by hitting mode and then looking at the third one down. Right now I'm highlighted as radian. I want to highlight degree. So I'm going to go down and then over to degree, hit enter. And now I'm in degree mode. I can hit second quit. And now I can do what I need to do. And I will type in 18 divided by tangent of 37. Make sure I close that parenthesis, hit enter, and that tells me 23.9 is the length of x. 23.9. So perfect. Now, that's x. And so that's great. But now I need to find y, right? Because ultimately I'm trying to find the perimeter. And so I need to get all the sides of this shape, and then I add them together. And so let's do y real quick. Now, in order to do y, we're still going to work with the 37-degree angle. But obviously, we now need to find y, so we have to use the hypotenuse. And let's still use the side where we know the number, right? So the 18. And so this time we're going to do opposite and hypotenuse. Opposite and hypotenuse is going to be the sine function, right? That comes from so. Sine is opposite over hypotenuse. And so we're going to do the sine of 37. Oops, that's the sim. Let's change that to sine of 37 equals, and it's opposite on top of hypotenuse, so 18 over y. And this algebra will work the same as the x algebra. So we'll multiply both by y, and then we'll divide by the sine. And so y will ultimately be 18 divided by sine of 37. So let's type that into our calculator. 18 divided by sine of 37. We hit enter, and that is 29.9. 29.9. And again, that's y. And then so our answer for the perimeter is going to be all three sides added together. The x side, which was 23.9, so 23.9 plus our 18 plus the y side, which is 29.9. And if we add all of those together, we should get roughly 71.8. There are no units, and so we will just box that. The perimeter is 71.8. All right, let's keep going. Another sine cosine tangent problem here. Well, this is actually a 30, 60, 90 triangle. I'd rather talk about sine cosine tangent though. So we need all the sides, right? So let's put an x here. Let's put a y here. We need to do the same thing as last problem. And so we're going to start with the 30. We're going to look across from the 30. That's our opposite. Across from the 90 is our hypotenuse, which makes y our adjacent side. So let's say we want to find x. Obviously, we're going to use x and then our 18. And so this time, if you think of SOHCAHTOA, we are using opposite and hypotenuse again. Opposite over hypotenuse is the so part. So that's our sine. So sine of 30 is going to equal, and it's opposite, which is x divided by hypotenuse, which is 18. And so this time, it's a little bit nicer. We're going to multiply both sides by 18. And while we do that, our 18s cancel on our fraction side, and it just leaves us with x. And so we've already got x, and all we need to do is type 18 times the sine of 30 into our calculator, and we got our answer for x. So let's do that. 18 times the sine of 30. Enter, and we get 9. So that's nice. So x is 9. So now let's find y. Y is our adjacent side. we want to use our hypotenuse as well, because that's where our 18 is, right? And so adjacent and hypotenuse is our cosine. And so for y, we'll set up cosine of 30 equals, and it's adjacent on top of hypotenuse, so y over 18. And then we get the same algebra as up above. Multiply both sides by 18. Our 18s and our fraction cancel out, leaving us with just y. And so then we just want to type in 18 times the cosine of 30 into our calculator, and that will leave us with y. And so when we do that, 18 times the cosine of 30, we get 15.6 roughly. 15.6. And so then our perimeter is, add everything together, the 18 side plus our x side, which was 9, plus our y side, which was 15.6. And adding all of those numbers together should give you roughly 42.6. This time there are units, meters, and so 42.6 meters. All right, perfect. Now let's try to finish up this last problem before our time runs out. Couple things real quick. This number 3 is problem number 3, so ignore that. That's not a number we're going to work with. It's problem number 3. It just got printed in a weird spot. And then secondly, we got to talk a little bit about rectangle properties. First of all, this is a rectangle, 4 90-degree angles, and then 2 opposite congruent sides. And so if it's 9 on the right side, left side's got to be 9. And so we just need to know the top and the bottom. However, this 7.5 is part of this diagonal. And so that has nothing to do with the top or the bottom yet. One thing you should know about rectangle properties, which we learned at the end of our Geometry A experience most likely, is that the diagonals cut each other in half. And so that part of the diagonal is 7.5, and so is this part. Which means that whole red line, which is our diagonal, is 15, right? 7.5 plus 7.5. And when I know that, and now I look at the rest of this shape, I can color in, a right triangle here in red. And so my right triangle will look like this, where this long side is my hypotenuse, that's 15. This right side is 9. Let's consider the bottom x, and I can do the Pythagorean theorem, a squared plus b squared equals c squared, to solve for x. And so x squared plus 9 squared is going to equal 15 squared. So x squared plus 81 equals 225. So we'll subtract 81 from both sides, and x squared equals 144. We'll take the square root at this point, leaving us with x equaling 12, which is huge, because now we know that the bottom of that triangle we were working with was 12, which means when we bring it back to our rectangle itself, the bottom's 12, and then the top is 12. Now remember that 15 represents the diagonal total, and so I'm going to get rid of that right now if my eraser works, and write 12 on the top. And so our perimeter then is simply 9 plus 12 plus 9 plus 12. So 9 plus 12 plus 9 plus 12. And when we add those numbers together, we should get 42 feet exactly. The single apostrophe means feet, right? All right, now we're running out of time for this video. As you can see, even though they seem simple, these are fairly involved problems. So I'll make a couple more videos here and we'll get through part 1 of notes. Thank you very much for your time.